This is problem 7C. If you have not watched the problem 7B video, please take a moment to watch that so that you get some general idea on the direction, what kind of direction we should go for this type of problem. So in this particular problem, this sequence is approaching 0, and we want to find the rate of convergence. And we have two functions in the numerator. One is sine, the other one is cosine. And also observe that for this cosine function, we have h extra term multiply this cosine function. So therefore, when I apply Taylor theorem to expand the sine and cosine, I want to find a higher order expansion for sine, one order higher than cosine, because when h times cosine, the power of h will increase by 1, right? So keep that in mind, and by the way, another key thing that you need to keep in mind is after simplification in the numerator, you should have only one single term left. So therefore, let's do that. Now, so I skip some work here, but I provide the background work for the expansion of sine. So I'm gonna use that. So my first term will be 0, right? Plus the second term will be 1 times x. Plus another term will be 0. Oops, I'm sorry, I should use h instead of x. So this is h. Another term will be 0 here again. Another one will be negative. Now, this is, should I continue to expand? Actually, I would say we will not. I'm going to explain the reason pretty quick. But in general, you will have to trial and error. So I already kind of do a little mental math. I see that that's the term that we will end. So therefore, this should be my error term, okay? So it's cosine of sine, no longer h. And then over 3 factorial h cubed. Similarly, for cosine, now please note that the highest order of this expansion is power 3. I want to stop at power 2 for my cosine h expansion, because there will be extra h when it will be multiplied by h. So therefore, I'm gonna do this expansion 1 plus this is gonna be 0 plus, so I know the next term will create x squared, right? Because this is 0 times x. So oops, not x again, should be h, because the h is the notation that we use. So therefore, the next would be my error term. So it's going to be negative cosine. Now, I already used xi here. This is a different function. This xi will not be the same as psi. So in order for me to don't get them messed up, I choose another symbol. How about I choose, say, alpha? It really doesn't matter, right? Cosine alpha. Just think of it as a xi, okay? But it's so that they're different. This will be 2 factorial, which is just 2h squared. Now, I'm gonna plug in both into this expression. So my sine h will be h minus cosine xi over 3 factorial, which is 6 h cubed, right? Minus. So now this is actually for my sine h. So the next one will be h times my cosine h, which is 1 minus cosine. This time, by the way, this is xi and this is alpha. They're different. 2h squared over h. I'm gonna drop parentheses. So for the this function simply dropped. Okay. For the next one, so I'm gonna quickly copy that down here. For the next one will be h plus cosine alpha divided by 2. And by the way, this is psi. Let's distinguish those two different symbols. There are two different variables. And then this is going to be h squared divided by h. So do you see that we actually can cancel this h with this h? I'm sorry, that when you multiply this in, this should be h cubed, right? This is h cubed, not h squared anymore, h cubed. Now after this is cancelled, we have a common factor h cubed in the numerator, so let's factor it out. So when you factor out h cubed, that's what you have. Over 6 plus cosine alpha over 2. And then h cubed is factored out, right? Over h. And cancel one h, we're left with h squared. Now let's bound. By the way, when we bound, we absolutely want to use the absolute value symbol, right? So I forgot to use absolute value symbol, so I'm gonna now add the absolute value. So less than or equal to. This is what we do. Do you agree that this guy, so this bound is very flexible. Do you agree that this term is absolutely less than or equal to 1/6, right? So I'm pretty sure it's less than or equal to 1/6. And 1/6 is, so I'm gonna just write down. Therefore, this is less than or equal to, that's why I can do that. I know this term is less than or equal to 1/6. Similarly, for this term, no matter what alpha is, it's gonna be less than or equal to 1/2. So plus 1/2, right? So this is my the bound, where the bound comes in, and I'm still left with h squared. I really don't care about what this value is. So the key thing is, I do know that this sequence now is converging to 0 at this rate, h squared. So now I can actually write my answer. Write my answer now. So I'm gonna say, hey, now I can say this guy converging to 0 in the order of h squared. So this is it.